Hi students, today we are discussing the topic the relationship between Cp and Cv for a gaseous system. That is, when heat is added to a gaseous system at constant volume. That is, when heat is, suppose this is a gaseous system, if heat is added to this gaseous system at constant volume. The condition is at constant volume. Okay, it is used up by completely to increase the internal energy of the system. According to first law of thermodynamics, that is delta U is equal to QV. That is, from the first law of thermodynamics, we have delta U is equal to QV. Delta U is equal to QV. That is, at constant volume, the internal energy change is equal to heat absorbed or evolved at constant volume. Okay. Hence, when heat is added to a gaseous system at constant volume, it is used up completely to increase the internal energy of the system, since no work is done by the system. Okay. But when heat is added to a system at constant pressure, what is happening? When heat is applied or added to a system at constant pressure, a part of heat is used for increasing the internal energy of the system and also for the expansion work. That is, at constant pressure, when heat is added to a system, a part of heat is used for increasing the internal energy of the system and also for the expansion work, that is P delta V. Okay, that is, when heat is added to a gaseous system at constant volume, it is used up to increase the internal energy of the system, since no work is done by the system. Okay, but when heat is added to a system at constant pressure, what is happening there? That is, a part of heat is used for increasing the internal energy and also for the expansion work, that is P delta V. Okay, hence we can say that Cp is greater than Cv. Okay, it is Cp is equal to what? Dou H by dou T P, and Cv is equal to dou U by dou T V. That is, Cp minus Cv is equal to dou H by dou Tp minus dou U by dou Tv. Cp minus Cv is equal to dou H by dou Tp minus dou U by dou Tv. Can put it as equation number 1. Okay, we know that H is equal to U plus PV. This enthalpy is equal to U plus PV. Differentiating this with respect to temperature at constant pressure. It is dou H by dou T at constant pressure is equal to dou U by dou T. Differentiating with respect to temperature at constant pressure, plus pressure is constant, taking outside, dou V by dou T P. Put it as equation number 2. Then 2 in 1. That is, we are substituting 2 in 1. Cp minus Cv is equal to dou u by dou Tp, it is dou h by dou Tp. For this value, we are substituting this term, P into dou v by dou T at constant pressure minus dou u by dou T v. Put it as equation number 3. Suppose use a function of any two of the variables pressure, volume and temperature. Here we are taking u as a function of volume and temperature. Since du is a complete differential, it is du is a complete differential, we can write it as du is equal to dou u by dou v at constant temperature dV plus dou u by dou T at constant volume dt. Equation number 4. Okay. Next, we are dividing both sides of this equation by dt and imposing the condition of constant pressure. Okay. This dou u by dou T at constant pressure equal to dou u by dou v at constant temperature dou v by dou T. It is differentiating with respect to temperature at constant pressure plus dou u by dou T, dou u by dou Tv, dt by dt cancel out. That is, here we are dividing this equation by dt at constant pressure. That is dou u by dou T at constant pressure, dou u by dou Vt and dou v by dou T at constant pressure, dou u by dou Tv and dt by dt cancel out. We are getting this equation. We are writing it as equation number 5. And finally, this substituting this 5, equation number 5 in 3, equation number 3. It is Cp minus Cv equal to dou u by dou v T, dou v by dou Tp plus dou u by dou Tv plus P into dou v by dou Tp minus dou u by dou Tv. That is, we are substituting this equation 5, that is dou u by dou Tp in equation 3, dou u by dou Tp is equal to, the first term is this one and we are writing this term finally. Okay, and this term cancel out and we are getting Cp minus Cv is equal to dou u by dou Vt, dou v by dou Tp plus P into dou v by dou Tp. Okay. This is our final equation, that is Cp minus Cv is equal to dou u by dou Vt, dou V by dou Tp plus P into pressure into dou V by dou Tp. Okay. Next, we are discussing the relationship between Cp and Cv for an ideal gas. That is, for an ideal gas, the internal energy depends only on the temperature and is independent of volume. That is, dou u by dou Vt term is equal to 0 for an ideal gas. Okay. For an ideal gas, the internal energy depends only on the temperature and is independent of the volume. Hence, this term dou u by dou Vt is equal to 0 for an ideal gas. Okay. We have Cp minus Cv is equal to dou u by dou Vt, dou V by dou Tp plus pressure into dou V by dou Tp. That is, for an ideal gas, dou u by dou Vt is equal to 0. Hence, this term becomes completely 0. And we are getting Cp minus Cv is equal to pressure into dou V by dou Tp. Can write it as equation number 1. For 1 mole of an ideal gas, PV is equal to RT. For 1 mole of an ideal gas, we have PV is equal to RT. That's what we are doing here. Differentiating this equation with respect to temperature at constant pressure. This here at constant pressure is used. P is taken outside. Differentiating with respect to temperature at constant pressure, we are getting this P into dou V by dou Tp equal to R. Okay. Then we can write it as equation number 2. From 1 and 2 we have Cp minus Cv is equal to R. This is for 1 mole of an ideal gas. This is for 1 mole of an ideal gas. Okay. For n mole of an ideal gas, we have Cp minus Cv is equal to Nr. These two equations are very important in thermodynamics. Okay. That is, for an ideal gas, the internal energy depends only on the temperature and is independent of the volume. Hence, this term dou u by dou Vt is becoming 0. Hence, we are getting Cp minus Cv is equal to only this term. Okay. Then what we are doing? Taking the ideal gas equation, that is PV is equal to RT, and differentiating with respect to temperature at constant pressure, we are getting this. And equating both, we are getting Cp minus Cv is equal to R. These two terms are equal. So we are writing like this. For 1 mole, Cp minus Cv is equal to R. For n mole, Cp minus Cv is equal to Nr. Okay. Here you can see the notes for the relationship between Cp and Cv for a gaseous system. When heat is added to a gaseous system at constant volume, it is used up completely to increase the internal energy of the system, since no work is done by the system. But when heat is added to a system at constant pressure, a part of heat is used for increasing the internal energy of the system and also for the expansion work. So, for a constant amount of heat dQ added, dt will be lower at constant pressure than at constant volume. Hence, we can say that Cp will be greater than Cv. Then Cp is equal to dou H by dou Tp, Cv is equal to dou U by dou Tv, Cp minus Cv, we are getting this. Then differentiating with respect to temperature at constant pressure, we are getting dou H by dou Tp is equal to dou U by dou Tp plus P into dou V by dou Tp. That is substituting equation number 2 in 1, we are getting this Cp minus Cv. And since U is a function of any two of the variables, pressure, volume and temperature, we are taking here volume and temperature. Since U is an exact differential, we can write like this as a complete differential. This dou U by dou V. Dou U by dou V at constant temperature dV plus dou U by dou T at constant volume dt. Dividing both sides by dt and imposing the condition of constant pressure. Okay, we are getting this term, that is equation number 5. And finally what we are doing? Substituting equation number 5 in equation number 3. We are getting this and cancelling both these terms. We are getting Cp minus Cv is equal to this term. This is very important equation. Okay. Here we can see the notes for the relation between Cp and Cv for an ideal gas. Okay. If you want notes, please take down notes. This equation is also very important in thermodynamics. Okay.